Question 4. We have solved the initial value problem of this second differential minus y equal to 0. And then we have the some conditions when x is 0, y is what? Y is 1. And then when first differential is 0, y the first differential is 1. Okay, let's see how we can, without wasting time, let's go straight to the action. We told us that the differentiation is first, that will be r, the second differential, that will be r squared. So the auxiliary equation, okay, is r squared. This is just a constant, just like the attachment, the coefficient is minus 1 equal to 0. So in this case now, this will be this is the difference of 2 squared, which will be equal to plus 1 equal to 0. Okay, so this is r equal to what? 1 or minus 1. So which implies that y1 is equal to what? Ex, and y2 is equal to e minus x. Okay, don't forget where we got this. You know, in the first video on this topic, we said the solutions of the differential equation is y, okay, is y equal to erx, okay, and our r in this case, the first one is 1, so 1 times x, that's that. The second one is minus 1, so times r minus 1 times x, times it now. That's how we got it. Okay, then the general solution will be c1 ex plus c2 ex minus. So that's the general solution. Okay. So in that case now, we have some conditions here. We have a first differential, certain conditions. And that means we can get the first differential of this y prime to be equal to, if we differentiate this, there's no change. This c1 is just a constant. You're only differentiating the exponential function, and the attachment to that power is 1, so it has no effect. So that's that. Okay, if it's maybe you have 2 here, that will be times 2. Then this one also has no effect. This one has effect because the attachment is minus 1. So that will change the sign here to negative. And that will be what? That will be minus C2. Yes. What I mean is that the derivative of the power here is minus 1. So times the whole expression there. Okay? That's C2. So let's now use those boundary conditions. For the first case, y of this equal to 1. This is x equal to 0. This is y equal to 1. Plug in that. S is 0. We have 1 equal to c1 plus x is 0. That's what? C2. Equation 1. For the one of differential, okay, we have y prime of 0 equal to 1. Plug in s is 0 also. Y is what? Y is 1. So that will be equal to 1 equal to c1 minus c2, equation 2. Let's solve this one simultaneously. Simultaneously, you can add the two equations together. When you add it together, you have this c2 will go, then we have 2c1 equal to 2. So c1 is what? Is 1. Okay, that's by adding. Also by subtracting 1 minus 2. Equation 1 minus 2, you have 0 equal to this c1 minus c2, c1 minus c1 cancel, c2 minus c2, that is 2c2, 2c2. So c2 is what? C2 is 0. Okay, so once we've gotten that, we just come back here to your general solution and plug in the value of your c1 and your value of your c2, and that will be y equal to, my c1 is 1, that will be ex. My c2 is 0, so that will be, it's gone. 0 times this, gone. So that's my general solution. That's a general solution. That's general solution, okay, to that. And the essence or the purpose of this condition is just for you to get your constant value, C1 and your C2. These are the reason for these given conditions. Okay, this one and this one. So that's that question. Yeah. The next question we have this. This is also the third differential, second differential, and this is constants. So the auxiliary equation, the auxiliary equation, the auxiliary equation of this differential is the third differential will be R3. I've explained that. I've said that first differential will be R, second differential will be R squared, and so on and so forth. And then minus the attachment here is 3, and then second differential R squared, and then this one is not differential, that will just be constants. That's 4 equal to 0. Okay? So what do we do here? What do we do? Let me check. So what we are going to do here is this is also polynomial of power 3 of degree 3. So what we are going to do here is to look for factors of 4. Okay, so let's first of all write this one as a function of r, which is equal to r3 and 3r squared minus 4. Okay, because we need to factorize this. Okay, so factors of 4 could be 1. 1 is also there. 1 times 4. 4 is also a factor. 2 also is also a factor. Minus 2 times minus 2 is also, minus 2 is also a factor. Okay, so let's begin to experiment with values. We are going to check with let's check with the smallest value, the smallest factor. If you put 1 here, 1, okay, 1. Let's begin the experiment. If it's 1 you are using, this is 1 minus 3 minus 4. So does it work? Does it equal to 0? So if it's not equal to 0, it's not a factor. It's not a factor. I think the question, there's a problem here. This is plus. This is plus. So if it's plus, so it's going to work. Okay, 1 will be a factor. Okay. So that means f of what? F of 1 is equal to what? This 1 plus 3 minus 4. Okay, and that's what? That's equal to 0. So therefore, in that case now, since the functions of r minus 1, okay, is what is a factor. R minus 1 is a factor. Okay, and then we can do the division and carry out the polynomial division so that we can factorize that, and that will be equal to what? R3 plus 3r squared minus 4 equal to what? R minus 1. Okay, so that means you're having r squared here, and then you can multiply this one times this one. That's R3. This one times this one. That's minus r squared. Then you can subtract. So you subtract, you have this one go. This is 3 minus this. That's what? 4 plus 4 r squared. Then you can bring the next value down, minus 4. So what can you use also to multiply this so that you can get your 4r squared here, and that will equal to what? Plus what? Plus 4r. Okay, multiply this one times this one, 4r squared. Okay, this one times this one, minus what? Minus. To arrange this division, before this 4, we're going to bring in plus 0r. Then we can now bring it down minus 4. We want to follow that sequential power 2, power 3, power 2, power 1, and then the constants. So that's what we're going to do there. So in this case now, it's going to be plus what? Plus, bringing down the plus 0 r. Okay, plus 0 r. Okay, so and this will be equal to what? Minus what? Minus 4 r. Okay, then you can subtract. You're subtracting 0 minus 4. And that's what? That's a plus 4 r. Okay, you can now bring this one down, minus 4. Okay, so what can we use to multiply this one? If we have the first one, so that we can get 4r, and that will be equal to what? Plus what? Plus 4. Plus 4. So 4 plus 4 times the r, that's 4r. And then 4 times this, minus 4. And don't forget that once it's a factor, you must have your remainder at 0. Okay, it's a factor, your remainder is 0. And you can also see here when we use f of 1, you see that's equal to 0. Okay, so then this now implies this plus this minus 4 is equal to what? Is equal to r minus 1 into bracket r squared plus 4r plus 4. Okay, we can finish that. Then we go to r minus 1 into bracket this. Let's factorize this. 4, that's 4 and 2, 2 and 2, 2 and 2 plus 2 plus 2, so plus 2 plus 2. Factorize this. Okay, so that and that means we're having this. Don't forget, is equal to this one equal to 0, and we have gotten the factorization for this expression, and that will be equal to r1 plus r2 into bracket r2 plus this is equal to 0. Okay, so r is what? R1 is what? Is 1. Then R2 is equal to R3. And they're both what? Minus 2. Okay? They're both minus 2. So the solution for this equation will be y1 equal to ex. Okay? y2 is equal to e minus 2x. And then y3 is equal to what? X e minus 2x. Okay? Don't forget what we said in the first video in this lecture on this topic, that the solution of the differential equation by surjection that is equal to E Rx. Okay, so with that now, your R is 1, put it there. Your R is what? Minus 2, put it there, you see it. Okay, but in this case now, R2 and R3, they are repeated roots. R2 and R3 are repeated roots, and that's what we have. The first one to be this, and the second one to be this. Okay, so the general solution will just be equal to what? General solution will be equal to C1, that's Y1, plus C2, Y2, and then plus C3, Y3, which is what? X, E, and 2X. So that's that on that question.